All right. As Lila said, I'm a psychologist by training, experimental psychologist. So today I'll try to give you an overview of mind wandering from a cognitive psychology and cognitive neuroscience perspective. And I'll touch on some of the topics that other researchers spoke about. So what I'll do is pretty simple. I'll try to define what mind wandering is from our perspective. I'll try to explain why we care about mind wandering. And then I'll introduce you to two big problems that we have in mind wandering research and some tentative solutions to these problems. So how can we induce this experience in the lab, and how can we try to capture it and measure it objectively? So what's mind wandering? This is a complicated question, but we all have an intuitive sense of what it is. So it's this kind of drift of attention from the external world to our inner thoughts. And this often happens when the external demands of the environment are low. So when we don't have much to do, for example, if we're sitting on the bus or on the train, if we're in our morning routine, for example, and our body can kind of go in autopilot, or it can even happen sometimes when we don't really want it to. So situations in which we should be focused, but we're not able to focus. So we all have this kind of shared idea, but as it often happens, when we really try to want to define a concept in psychology, that's where the problems arise. So if you go and look at the literature, you find an incredible range of terms, and I've added some like visual imagery and earworms since 2 days ago. So why do we have all these terms? It's not just because humans are bad at agreeing with each other, but it's probably because all of these terms capture different sub-aspects of the same family of phenomena. So Ruth touched on this, that maybe we shouldn't just think as mind wandering as just one phenomenon, but more of a family of phenomena that all share some characteristics. But of course, when we want to study it scientifically, we need to try to have a kind of better definition. So one way that you can do this is you can try to define some dimensions of thought. So if you imagine in a typical psychological experiment, you have a participant sitting in front of a computer, and his thoughts can be related to the task or unrelated to the task. This is one dimension, so task relatedness. And they can also be guided by the external world, by perception, or his thoughts might be just self-generated. So in the ideal scenario for a psychological researcher, the participant is thinking just about the task, and what's going on through his mind is directly guided by the stimuli that he's seeing. So this is some kind of numerical task, for example. And what if his thoughts are still guided by perception, but they're unrelated? For example, you hear a noise, so the participant stops thinking about the task, but his thoughts are still defined by a stimulus that is external. While on the other hand, your thoughts might be related to the task, but they might be self-generated. For example, this participant is tired of doing the task. And at the final stage of these dimensions, you have thought that is self-generated and also task unrelated. And this is usually in cognitive psychology what we define as mind wandering. So you're not thinking about the task, and your thoughts are completely unrelated. So why do we care? We care principally because mind wandering is so common and it pervades our waking life. And Lila touched on this on the first day. There's different estimates of how common mind wandering is. Different studies, ecological studies, try to find a number. So you have different estimates, but more or less we can say that about 30% of our waking lives are spent mind wandering. So it's something that happens incredibly often. We're all very familiar with it, but we still don't know a lot about it. What we do know is that mind wandering comes with benefits and costs. So one of the most common findings in psychology is that most of our mind wandering is related to the future. So if you ask participants what they're thinking during a task, and then they tell you that they are on task or off task, and then you also ask them to tell what kind of temporal dimensions their thoughts have. Obviously, when they are on task, they usually say that they're thinking about the present right now. This is not surprising, but when they're off task, the majority of times they will tell you that they're thinking about the future. And not only about the future, but this is from another study, usually it's about our recent future. So maybe something that will happen later today or tomorrow maybe. So this suggests that maybe mind wandering has some kind of adaptive property of preparing for the future, planning for the future in situations in which you don't have to do anything in the external world. You're sitting on the bus and you have time to prepare and think about what you will do later on. This is another study that found that this kind of what we call future bias increases when the mind wandering is of an intentional type. So again, this suggests that when we're actually free and we engage intentionally in mind wandering, we tend to think about the future even more. Unfortunately, we know that mind wandering also comes with costs and costs in performance. So when we mind wander in situations in which we shouldn't, this comes with costs. For example, this is a study using a high-fidelity driving simulator, and researchers found that your response time, your reaction times to sudden brake were slowed when you were engaged in mind wandering. And it's not only in driving simulations, but this is a meta-analysis looking at the responsibility and the factors that cause responsibility in car accidents. We can see that mind wandering with highly distracting content was a pretty strong predictor of accidents on the same kind of scale of other more commonly known factors like alcohol use. So there's definitely a cost there. So we would like to know a bit more about mind wandering, but unfortunately there's two big issues that we run into, and these are issues that are common to many fields of consciousness research in psychology. So one of the problems is that you're trying to induce in the participant what is basically defined as spontaneous phenomenon. The other problem is that we're trying to capture and measure a private experience, an intimate experience. So how do we try to overcome these two problems? Let's start by the first one. So we already said that mind wandering is more common in situations in which the demands of the environment are very low. So it would be appropriate to mind wander if you're sitting on the train, but of course if you're doing something extremely engaging, my guess is that this pilot is perfectly coupled to the external environment and is not thinking about what he will eat the same night at dinner. So we know that mind wandering is modulated by demands. And we also know that eventually, even when we should focus, with enough time, people will start to drift off into their own thoughts. And this might be because, for example, Ruth spoke about this, might be physiological cycles that underpin this phenomenon. So it's impossible to focus on the external environment forever. At some point, you will drift off. So how can we use these facts that we know about mind wandering to try to induce it in the lab? So we could either bore participants to death by using a 3-hour task and waiting for them to mind wander, and this is actually what sometimes they did in the 60s. Or you can try to do some different things. So these are just two experiments that show these two facts that I told you about. So in the first study, it's an old study, as more information was presented to the participant and they had to encode more information, their mind wandering dropped. So again, this is when the demands are low, you mind wander more. And this is another study that shows that mind wandering increases with time throughout blocks. So how can we use these two facts? So we can try to build a paradigm that modulates continuously the demands of participants. So this is what we do. So in this task, you have two different subtasks or two conditions, which we call 0 back and 1 back. So in one condition, let's say the 0 back, what you see, so this square would be the screen that you're seeing on the monitor. You see pairs of shapes, and then you have a fixation cross, and then you see another pair of shapes, and so on. And then at some point, the shapes will be colored, fully colored, and you also have a small shape in the middle, which will always be one of the two. So in this case, what you have to do is press the left arrow key or right arrow key, depending where the shape that is shown in the middle is, if left or right. So this is an incredibly simple task, right? The square is in the middle, so in this case, you would have to press the left arrow key. So you'll be doing a bit of the 0 back, maybe 1 or 2 minutes, and then we make you switch, and you do the 1 back task. Again, you see pairs of shapes on the screen, but the difference is that when a target comes, you will have 2 question marks and then a shape in the middle. So in this case, you have to tell me where the shape in the middle was in the previous set of shapes. So in this case, you would have to press right because the square was on the right. So this is a kind of classic 1 back working memory task. So why do we use this? We do this because we are showing you the same stimuli. So the environment is showing you the same things. But a participant quickly realizes that in the 0 back task, you don't need these shapes. So in order to do the task correctly, at some point this shapes will flash, and you will have all the information that you need to make a correct response here. While here, you realize that you never know when a target is coming. These are semi-randomly presented. So you have to focus on every set of shapes, and you need to encode them, and you need to be careful, because if this comes, you will have to remember where the square was. So we try to modulate the internal experience of participants in this way. And this is where you would make a response. So it would look something like this. So pairs of shapes, fixation cross. These are for like about 1.5 seconds. And then, okay, where's the square, left or right? I press left. And then you go to the 1 back task again. Where was the square? It was on the right. So what this does is that it creates periods of times that are pretty long. It's over here, in which the participant is free to drift off into their own thoughts. And we can compare these periods of times with these other periods of times in which the same stimuli are presented, but we assume that you're coupled with external environment and you're very focused. So how do we measure mind wandering using this? Well, it's easy. Instead of the targets, sometimes you can present what we call a thought probe. So we interrupt the task and a screen pops up, and we ask you to rate your focus. So there's different ways to do this, but essentially we ask you to tell me, were you on task, were you just thinking about the task, or were you off task, were you mind wandering about other things? And for example, here you have a scale. So this is how we try to measure mind wandering, and when you run this task, what you find typically is that so your response times will be slower in the harder 1 back task, because it is a harder task, and your accuracy will also be lower, and your task focus will be higher in the 1 back task and lower in the 0 back. So we're able to modulate your task focus to some level. So this is a bit the easier problem, I guess, the inducing mind wandering, because it happens. While the harder problem is trying to get an objective measure of mind wandering. So experience sampling is what we use now, and it's kind of the golden standard. So you have different methodologies. The prop code methodology is what I explain now. So we just randomly probe you and we interrupt you during the task, and we ask you, are you mind wandering or not? This is the most commonly used. And of course, it's not a perfect measure because, first of all, in order to measure the phenomenon, you're interrupting the phenomenon. And this is the main issue. Also, after I interrupt you maybe 2, 3, 4 times during a 20-minute, 40-minute task, at some point you will start to think, what is this task about? Is it about what I'm seeing on the screen, or is it about my mind wandering? So it might give away the purpose of the experiment. You can also have self-caught methodologies. So in this case, we never interrupt you, but we tell you every time you catch yourself mind wandering, you should tell us, maybe with a button press or something like this. This is nice because we don't artificially interrupt your experience, but you risk conflating self-awareness of mind wandering and mind wandering. Because of course, with this methodology, you will never catch moments in which the participant is mind wandering, but did not realize it yet. Then you have retrospective methods. So these are essentially questionnaires. For example, that I would just give you one questionnaire after you've done your 40-minute task. So again, I'm not interrupting you, but then I'm assuming that you're able to give me a kind of measure of your average mind wandering throughout the whole task. And then you also have open-ended methods in which we don't ask you to categorize your thoughts, but we give you a blank screen or a blank sheet of paper, and you just tell me what you thought about freely. So you have different ways. The problem with self-reports, and there's many, mainly they are subjective. So in science, we want to try to have an objective as possible measure, and self-reports are inherently subjective. Also, we know that people sometimes can confabulate. So for example, if I give you a target and then you miss the target, and then I ask you were you mind wandering or not, maybe you will tell me that you're mind wandering because you did a mistake, but we cannot really know for sure. As I said, thought probes disrupt the experience itself. There's also a problem about the privacy and intimacy of our mental content. So there might be forms of mind wandering that participants never reveal to us and never tell us because they're private. So we would miss all of those with this methodology. And also there's all kinds of memory effects. For example, with questionnaires, after 40 minutes, you might forget or you might distort your memory. So how do we get a better measure of mind wandering? So we propose that one way is to combine different measures, starting with self-reports, then using maybe behavioral markers, so we know that when your mind wanders, you make more mistakes or you're slower, and then trying to find a neural correlate on mind wandering. So when you have these different measures that should explain overlapping variants, but not the same variants of your phenomenon, then you can try to find the variance that is common to all of them, and you will have a better measure of mind wandering. So we have self-reports already, and we know a lot about behavioral markers of mind wandering. What we really miss is a good neural correlate of the phenomenon. So we'll focus on this. And there's two candidates. One is the Default network, and you know this already because you heard it. And one is pupil dilation. So these are the two best candidates, I would say, as a physiological marker of the experience. So let's start by the Default network. So it's this set of areas in our brain, namely the medial prefrontal cortex, posterior cingulate, and then angular gyrus here on the sides, which are active at the same time. So we say that they're functionally connected. When you're at rest, when you're mind wandering, when you're not usually doing something that is very engaging in the environment. So this network was initially found because it tended to deactivate when you were very focused on doing something like a working memory task. You would find that this network, this set of areas would deactivate. So at the beginning, this was dubbed as the task negative network. Then people started realizing that when this network, if this network is active during certain moments, like for example at rest, it might be linked to what we also happen to do phenomenologically when we are at rest, so mind wandering. So these are 3 different studies that all use experience sampling in the scanner that found that your default network was highly active in the moments before you reported having a mind wandering episode. But not only for mind wandering, this network has been found in a range of other psychological tasks. So for example, in semantic processing, so if I show you a string of letters on the screen and you have to tell me if that is a word that has a meaning or if it's a non-word. If I ask you to imagine the future, if I ask you to think in creative ways, or for your autobiographical memory or theory of mind, we always find this kind of same set of areas. So then the question is, what is the default network really doing? Is it really linked to some kind of mind wandering? Is there something that is common to all of these forms of cognition? And our hypothesis was that the one thing that is in common with all of these is that your brain, your cognition is processing stimuli that are not presently available in the environment. So luckily we had the right task to test this. As I said, with this task we try to modulate the participant's experience, but it also provides us with different periods of time in the 2 different conditions in which you should be focused on the external environment. So as we said here, you need to encode these targets and you need to be very careful. And here you should also be coupled to the external environment because that's where the information to make a correct decision is. On the other hand, you have these other periods of time in which your internal attention might be more pronounced. So in here, you quickly realize that you don't have to focus and you might start drifting off into your own thoughts. While here, you need to recall from your working memory where the target was. So we made participants do this task in the scanner, and then we looked at these 2 periods of times in which we think your attention might be more innerly focused. These are the areas that we find. So there's a set of areas, some are in common and some are separate. Oh, sorry, spoiler. So there's certain areas of the default mode network here, as you can see, medial prefrontal cortex, posterior cingulate cortex. There's also, when we assume that you're mind wandering here, there's the hippocampus is very active, while when you're here responding to this one back target, you also have posterior cingulate medial prefrontal cortex, together with more classical working memory areas like the DLPFC, the dorsolateral prefrontal cortex. So the next step was very simply, what are the areas that are in common between the 2? Is there a common substrate that helps you mind wandering about your own thoughts, but also perform a task correctly based on information that you had previously encoded? And well, what we get is these 2 main hubs, again, medial prefrontal cortex and posterior cingulate cortex, that are shared between these 2 different periods of time. So what does this tell us? Well, for once, again, we find that the default mode network is just not task negative, it's directly involved in task positive cognition. And this also tells us that while the default mode network could be necessary for to support a mind wandering state, it is not sufficient to describe one. So you cannot just see the default mode network light up and assume that, oh, that's a great marker of mind wandering, of course, because we see that it's active in a different range of tasks. And so we should not make the mistake of confounding this spontaneous activity with spontaneous cognition. Indeed, the default mode network is found also in very simpler mammals. Like you can find very similar areas in mice that are active together, and we assume that they don't experience the same rich phenomena as we do. So what about pupil dilation? So pupil dilation is interesting to psychologists Because our pupils constrict and dilate mainly for 3 reasons. So 2 are physical reasons, so our pupils change and constrict with bright lights. They also constrict something that's called accommodation reflex when we focus on an object near us. And importantly, the 3rd reason is they change and dilate in response to psychological phenomena, psychological stimuli. So this was known at least since almost 60 years. So this is a seminal study in which female and male participants were shown different types of pictures, and then their pupil dilation was measured. And we can see that pupil dilation changes and increases in response to stimuli that are of interest or are arousing for us. But not only for arousal, pupil dilation also changes and increases with cognitive effort. So in this study, they were measuring the pupil dilation of participants while they were involved in a short-term memory task. So for example, repeat these 5 digits, 7 digits that I will tell you right now, and you have to repeat them. Or a long memory, long-term memory task, in which maybe you have to tell me numbers that you memorized 1 month ago. And we see that the harder task shows a larger pupil dilation. So what about pupil dilation, mind wandering, and attentional states? It's also been studied quite a lot more recently. So a common finding is that your pupils are usually abnormally large just before you make a mistake. So the 0 point is where a target was presented. And then if you look back how your pupil looked, you can actually kind of predict if you were going to make a mistake or a correct response based on your size, your pupil size. Regarding mind wandering, there have been contrasting results. So this was a study that researched mind wandering during reading. And in this case, they found that the pupil dilation was larger when participants said that they were mind wandering during reading, while compared to when they were on task. But on the other hand, many studies found more or less the opposite. So that mind wandering, I think you cannot see it, but it's this bar plot here, was smaller compared to being on task, which is here, while being externally distracted, so distracted by some other kind of external stimulus, would increase your pupil dilation. So we have this kind of contrasting results. So what we wanted to do is try to settle this uncertainty, and also looked a bit deeper into mind wandering as a phenomenon. So again, we use the same task that I explained before, and sometimes we presented you with behavioral targets that you need to respond to, or thought probes. And then we looked at how your pupil size looked in the approximately 4 seconds before either a response, a target response, or a thought probe. So in this way, we can go and look how your pupil looks when you make a mistake or a correct response, or when you're telling me you're on task or off task. And as I said, we wanted to go and look a bit deeper, so we didn't only ask you, my thoughts were focused on the task I was performing, yes or no. We also asked questions about the content and the form of your mind wandering. So these are different questions. Can you read them? Can you see them? Yeah? Okay. Right, so what do we find? So in general, when you look at mistakes and correct responses, we replicate previous results in which your pupil size is larger when you make a mistake. And when you look at reaction times, so your pupil here, your pupil baseline, is on the x-axis, so this would be a larger pupil size. And these are your response times. So the higher up, the slower your response time, so the worse your performance. Well, you find a linear relationship that is true in both tasks, in both conditions. So again, the larger your pupil dilation, the worse your performance is. What about task focus, which is the thing that we were really interested in? So again, you have your pupil here on the x-axis, and then you have your on-task versus off-task reports. So the higher up, the more on task you are. And deep down here, you're completely off task. So again, we find a linear relationship in both conditions, although it was stronger in the zero back. So when participants report being more on task, their pupil size is also larger. So you have seemingly opposite results when you look at behavior and self-reports. What about the content and the form of mind wandering? So as I showed you, we presented participants with 10 different questions. And then to control for the possibility of co-occurrence of responses, so for example, there could be a trend in which every time the participants say that they think about the future, they also say that they think about themselves. So maybe themselves planning something in the future. So we do a principal component analysis, and we find different components of thought. So these are the 6 components that we find. So for example, future and self, or being positive, this is your emotion, so you have a good mood, positive mood, and you're on task. Words and images, not surprisingly, are in one component, but they're opposed. So it looks like when participants say that they're thinking in words, they also tell us that they're completely not thinking in images. So this is a good sanity check. So how is your pupil and the context, the task that you are related to these components of thought? So there's different things to see here. So some things are explained, some of these components of thought are more common in one task or the other. So when you add the task, the condition, as a factor in your model, you can see that certain types of thought are more common in one task or in the other. So for example here, when you're in the zero-back task, you will have more future and self-thought. Or here, for example, you have more intrusive thought. While when you add also pupil to pupil baseline, your baseline pupil dilation to the model, this explains only 2 factors. So one is this off-task, being off-task and also thinking about the past. You see there's a linear trend with smaller pupil sizes showing an increase in this type of thought, and also with your intrusiveness. So you rate your thoughts as being more intrusive. So what can we summarize? So pupil dilation is pretty good. We can say that it can track different attentional states. But its capacity to actually track types of mind wandering really depend on the content of mind wandering. As we saw, in this case, pupil dilation was only able to track 2 different types of thought, and also the context in which it occurs. In this case, being in a high external demand environment or in a low demand one. And also, what we see is that there is a danger. So as we said, ideally, we would like to try to use behavioral measures and self-reports in the same way. But in our case, they were basically telling us opposite things. So pupil dilation was very large when you were bad at doing something, but also when you were telling me that you were actually on task. So this is something that we need to understand better. So to conclude, in general, as I think other researchers pointed out before, mind wandering is of course a term that maybe we can all use and agree on, but I think it's important to understand that it's not just one thing, but it's a family of these thought phenomena that they might share some characteristics and might be different on other characteristics. We think that developing a kind of physiological or objective marker of the experience will be the first step in order to have a very accurate and objective measure. And in the end, we also think that the content and context, they're just not, you cannot sacrifice in your measure the content and context of mind wandering, because as we saw, they can be key in understanding the phenomenon and measuring it. So I would like to thank these guys. They were more or less all at the University of York. This is Johnny, my supervisor, and the DSTL, which funded my PhD. Thank you.
Thank you so much. Thank you so much, Mahiko. I think this was such an important contribution to the workshop and very fascinating research. I would like to ask something. I wanted to ask if you have used pupil dilation also to look at different types of mind wandering, like unintentional or intentional, and if not, if you think this could help also to be, could be potentially a good signature for differentiating.
Yes, I have not, but so actually, so this guy here is Paul Seeley, and he works a lot on this differentiation between intentional and unintentional mind wandering. So Paul, if you're hearing me, maybe we can collaborate again, and we can do a pupil dilation study.
And do you also, I wanted to ask very quick question, the time frame that you use to measure pupil dilation?
Yes. So we were collecting data on 250 hertz, but then we downsampled a lot because when you do this, you get these massive data sets with a measure of your pupil every, I think, 8 milliseconds. But we can downsample that because actually your pupil dilation changes in, we were interested in your kind of tonic baseline over a span of seconds. So we're actually downsampling to, I think, maybe 30 milliseconds or something like that as with each measure. Yeah.
Thank you. Other questions?
Maybe I have another pupil dilation question then. How do you account for the possible confounds with emotional responses, arousal? Is this something that you thought of? I'm thinking especially in the case of music, where pupil dilation is more and more used as an indicator of an emotional response.
Yeah.
Is this something, that could confound these results?
Okay. Well, in general, our stimuli are very neutral, so we assume that anything that, unless you have some kind of phobia of squares and triangles, you shouldn't have an emotional response to the stimuli, but you might have some kind of emotional thought. So we try to capture it with this question, which is I can go back maybe, let's see if I find it. So we had one kind of emotional question, which is the content of my thought was, and then you have the scale, you can go from positive to negative. And as we can see here, this was part of this component. So when here, this would be one component of thought. So here we see that when you say that your thoughts were positive, you also said that you were on task. And well, we didn't find anything with pupil size. So maybe because of the nature of our stimuli, there was no real strong emotional response. But of course, if you use music, then that could be actually the measure of interest for you, depending on what you want to find out.
Thank you. Thank you for the talk. I have a question, or maybe it's more of a comment or a thought of mine. The most interesting question for me was your quest for neurocorrelates of mind wandering, and when you described, which I really liked, the different forms of or family of phenomena, you had these also the nice little movies going with it, and the different situations of people. So the girl looking out of the window, being sort of So those seem to be, for me, quite different mood sets that we're in, especially the bottom right one, of course. So it's, I guess there might just not be one correlate, because I think what we're looking for here is having thoughts that go somewhere under a certain mind state. And the mind states are very different in these examples. Does that make sense?
Yes, yes. And I mean, I agree. So in some sense, as we said, these are probably family of phenomena. So they might all be different to some level, but I think most people would agree that there still should be something that is common. So maybe some kind of form of thought that should be common to all of them. But probably we don't still have the means or the resolution in our measures to find what this common thing is. So yes, as we said, these are definitely family of phenomena which all share some things and are different in other aspects. I guess the big question is what are the dimensions? Can we find some orthogonal dimensions that allow us to explain all of these different forms? I guess this is the hard part.
I'm interested in the concept mind wandering, and you mentioned the content is also very important. But what is exactly meant by the content? So does it mean that mind wandering has to have a concrete kind of semantic content that is representational? Because why I'm asking is exactly in music listening, we can actually have this kind of visual imagery having concrete content, but you can also just mind wandering without having any concrete content. So my question is, when can we speak of mind wandering? So it seems to be only possible if we have the content. So is it right, or is it possible to extend the idea of content in terms of directedness, kind of intentionality? So this is my question. Okay.
I think in our case, when we talk about content, we try to define again some dimensions of where your thoughts might go. So usually this is what we do is, for example, we find like some kind of temporal dimension. So your thoughts might be related to the past or the future, or to yourself or to other people. So we try to find, ideally we would try to find the minimum amount of dimensions that allow us to describe what you're thinking about. So we use different types of questionnaires or open-ended methods. Actually, the dream experiment would be to recruit 1 million people, and they all give an open-ended summary of what they're thinking about for like 1 year, and then maybe you do some kind of text mining and you decompose all these open-ended methods, and maybe you find some things that are common in the content of people, some things that most people think about and that you can kind of find shared. But I was curious, I'm not sure. So you said that with the mind wandering in music, sometimes you might mind wandering without any content. So what exactly? So what would you mean?
Yeah, this is exactly. I think other people are more expert, but emotions, of course, have object, but we also have. Yeah, this is a kind of emotional research area question thing, but feelings or moods that are not exactly related to the concrete object, but we have.
Okay. I see. Okay. Well, in general, when we talk about content, it's not just like physical objects. I think most people would agree that if you have a feeling of happiness, for example, that will still be content based. So I wouldn't say that you can't have mind wandering without content, because in some sense the content is part of the experience itself, so of your phenomenological consciousness. So maybe you're not thinking about a concrete object that's out there, but you're feeling some kind of emotion or something like this, and that would be the content of that experience in that case.